Question 2. Period 3 elements sodium to sulfur all react with oxygen from oxide. So these are the oxides. And is from basic to amphoteric to acidic. So from SiO2 onwards, they are all acidic oxides. Okay, part A. State the trend in the acid-base behavior of the oxide of period 3 elements from sodium to sulfur. Across period 3 oxide, they are more acidic. Part B. State and explain the trend from sodium to sulfur in the maximum oxidation number of the period 3 elements in their oxide. Okay, so we know that from here, this one is positive 1, positive 2, positive 3, positive 4, positive 5, and positive 6. So it always increases across the period. Okay, across a period, maximum oxidation number increases. Okay, this can be related, because it's asked you to explain the trend. This can be related to the increasing numbers of valence electron, because we know that this one has 1 valence electron, magnesium has 2 valence electron, this one has 3 valence electron, and so on. Right? So the numbers of valence electron will determine the maximum oxidation number of these elements in the compound or in the oxide. Part C. Sodium oxide, Na2O, and phosphorus 5 oxide normally is referred to P4O10. Better to relate to P4O10. Okay, both oxide reacts with water. Name the product. Don't give formula, must give the name. Sodium hydroxide will form from the reactions between the sodium oxide with water, sodium hydroxide. So don't put NaOH, put sodium hydroxide, name it. When the P4O10 reacts with water, it will form one acid only, H3PO4. Many candidates forgot the Roman number. You must put this. Okay, the oxidation number of phosphorus must be there. Oxygen, now we have 4 is negative 8. Hydrogens, 3 hydrogens, so positive 3. Negative 8, positive 3, the acid now is neutral. Phosphorus must be positive 5. So we know that the oxidation number of phosphorus is 5, so it's phosphoric 5 acid. That's the name. Okay, part D. Explain why phosphorus 5 oxide has low melting point, which about 300 degrees C, but magnesium oxide has a very high melting point, around 2850 degrees C. Okay, explain why, then you have to relate with the structures and the bonding. Okay, first, P4O10 is a simple molecular structure, and between the molecules, it just has a weak van der Waals force. Magnesium oxide is giant ionic. Within the structure, it has ionic bond. There's a difference between them. So you have to explain based on this. Okay, the melting of phosphorus 5 oxide involve the breaking of van der Waals force. So when it's melt or boil, it must just the van der Waals force, which is the intermolecular force between the molecules. The melting of magnesium oxide involves the breaking of ionic bonds, or you can mention this electrostatic forces between the cation and anion, or you can say magnesium ion with oxide. Okay, obviously the ionic bonds is much stronger than the van der Waals force, which is the intermolecular force. Okay, part E. Aluminum oxide reacts separately with both acid and alkalines. Okay, these two equations must remember. and it's very common. Okay, aluminum oxide with HCl is just like normal neutralization, so it will form salt and water. The salt that form depends on the acid. If we use HCl, then it will form AlCl3. If we use HNO3, then it will form AlNO3 bracket 3. Okay, depends. So if let's say now it's hydrochloric acid, so it's going to be this equation. Okay, oxide with acid forms salt and water. Second, write an equations for the reaction of aluminum oxide with the excess aqueous sodium hydroxide. This one, you have to be careful because many candidates they'll forget this part. Aluminum oxide with NaOH must together with the water, aqueous. So when aluminum oxide with this NaOH and H2O, then it will form this compound. This compound is soluble in water, aqueous. Okay, NaAlOH bracket 4. Part F. Describe the structure of silicon 4 oxide. Okay, your answer should include reference to the arrangement of silicon and oxygen, how they arrange, what is the structure, and the bonding. The bonding very easy, it's just covalent bonding. The structure is tetrahedral, right? Okay, so silicon 4 oxide has giant molecular structure. It's a giant network. Okay, something like this. Each silicon will form 4 covalent bonds with oxygen. This silicon form 4 bonding with oxygen. This silicon also same. This silicon also same. But oxygens will form 2 covalent bonds with the silicons, right? And the structure is tetrahedral structure. Okay, part G. Sodium oxide Na2O and the silicon 4 oxide SiO2 reacts to form sodium silicate. Already given this formula. So part 1, you just need to give the equation, follow this statement. So this one react with this, form the sodium silicate. It's not easy. Part 2, the thermal decomposition of the sodium carbonate forming the sodium oxide and carbon dioxide also need to follow the instruction or the statement. So carbonate will form oxide and CO2. That's all for this question. Thank you.